Have you ever really thought about the incredible, invisible science that has to happen before a single pill ever reaches your medicine cabinet? Well, today we're going to pull back the curtain on a process that is absolutely crucial for making sure the drugs we all rely on are not just effective, but totally and completely safe. It's a really simple question, right? But the answer is pretty fascinating. When you take any medication, you're placing your trust in it. You trust that it has exactly what the label says it has, in the exact right amount. But how can we be so sure? How do scientists actually verify that?
Well, the answer involves a kind of chemical detective work. Scientists have to perform these incredibly precise analyses to measure the exact quantity of the active ingredient in any medicine. It is all about quality control, and it starts with a really fundamental chemical technique.
And that is the key phrase for today, redox titration. Now, I know it sounds a little complex, but it's actually an incredibly elegant and powerful way to measure the concentration of a substance. And to really get it, we need to zoom way in, down to the tiniest level of chemistry.
At its very heart, a redox reaction is kind of like a chemical dance, where the dance partners are constantly exchanging something super important, electrons. And it's this fundamental exchange that lets chemists perform their measurements with just incredible accuracy. So let's just define it real quick. A redox reaction is simply any chemical reaction where electrons move from one substance to another. And when that happens, two things happen at the exact same time. One substance is oxidized, and the other is reduced. You literally can't have one without the other. They're a package deal. And this little chart shows the two sides of that coin perfectly. Oxidation? Well, that's just the process of losing electrons, and reduction is the process of gaining them. It's a perfect partnership of give and take, and this transfer, that's the engine that drives this whole analysis.
So there are actually a few different ways to do a redox titration. But one method really stands out in pharmaceutical analysis because of how reliable and precise it is. And that method is called cerimetry. You can think of it as the gold standard for this kind of work.
The absolute star of the show in cerimetry is a specific type of cerium ion. It's a really powerful oxidizing agent, which just means it's fantastic at grabbing an electron from another substance. And when it accepts that one single electron, its charge changes. This simple, clean, one-electron transfer is exactly what makes the whole process so predictable and effective.
So what does this actually look like in a lab? Well, imagine we're testing a sample of something like ferrous sulfate. First, we prepare our sample, then we make the solution acidic. And then, very slowly, we start adding our yellow cerium solution. We just watch and wait until the reaction is totally complete, which is signaled by a sudden, super sharp color change to a pale blue. That's the endpoint, and it tells us exactly how much ferrous sulfate was in our sample to begin with. Now, cerimetry wasn't always the main method. For a long time, another technique was way more common, but, well, it came with a whole host of problems. So let's see how the new way stacks up against the old.
Yeah, the old guard was a method called permanganometry. It uses potassium permanganate, and look, it gets the job done, but it is notoriously fussy and unstable, and that is a major problem when you need your results to be absolutely perfect every single time.
And when you put them side by side, the differences are just stark. The permanganate solution is unstable, it's difficult to prepare, it breaks down in light, and you can't even store it for very long. But the cerium solution used in cerimetry, it's incredibly stable, it's simple to make, it's not affected by light, and you can store it for months without it losing any potency. I mean, it is a clear, decisive win for cerimetry on every single front.
But why does all of this matter so much? I mean, who cares if one solution is a little fussy? Well, in the world of pharmaceutical quality control, consistency and reliability, they aren't just nice-to-haves. They are absolutely 100% essential. And this right here really gets to the heart of it. A testing solution that isn't stable simply cannot be trusted. Think about it. If your measuring tool, your chemical ruler, changes from one day to the next, all of your measurements are going to be wrong. And that is a risk you just can't take with medicine.
So when you add it all up, the advantages of cerimetry make it the obvious superior choice. Its solution is rock-solid stable. It can be stored for ages, it's not sensitive to heat or light, and the leftover stuff from the reaction is colorless, so it doesn't get in the way of your readings. Plus, it gives you that clear, unmistakable endpoint. This is what reliability looks like in a chemistry lab.
And that brings us all the way back to our very first question. How do we know what's in the bottle? We know because of rigorous, reliable tests like cerimetry. This unseen science is truly a guardian of our health, making sure that every single dose of medicine is exactly what it claims to be.
It really makes you wonder, doesn't it? Cerimetry is just one single example of the hidden chemistry that underpins the safety and reliability of our modern world. So what other crucial processes are out there, working behind the scenes, keeping everything running smoothly for all of us?